Now CTC loss, we have two functions, train and infer, right? Training we will do, and inference is like prediction. So again, as I've said, input image pass to CNN, we'll get feature table, like timestamps. Using RNN we will get each character source versus timestamp matrix, and then using CTC we'll again backpropagate. We can backpropagate till RNN, or we can backpropagate till features. Like entire neural network we can update using training. Once that is ready, we can just do prediction step from CTC, because matrix has been ready. So we just need to pass the input image. We need to see the matrix which is constructed using the trained model. Using that matrix we will run some heuristics, or we will have some metrics. With that we can take like most probable or another techniques which we'll talk. Using that we will get the text what is written on this image. So sample hand text image has been converted to simple text. So these things we are going to see. So CTC solves both problems for us. So I was talking like why we want to use CTC. So as I've said, like similar to whatever the hand text recognition or speech recognition, like position, pace, length, width, all those factors matter. So it is hard and time consuming to annotate a data set on character or say word level also. Like if you have a total this is the entire image. For example, this is the entire image and it is hello over here. So we can't like divide into timestamp and say this is H, this is E, or this is half H, again H, and this is L. Like per timestamp or word level basis or letter level, it character level basis, we can't annotate in a training set. What we'll having in the training set is this is the entire image, and like this is the input. For that output will be hello. It will be like this only. We can't say this timestamp is H, or this timestamp is half H, again then H will go, this timestamp E, this timestamp is L, and again another timestamp L, O. We can't like annotate this. This is time consuming, a lot of labor work. So these things will not be like mostly in industry standards will happen. And again, this is just for one image. We have so many like lakhs of image for training high level hand text recognition or speech recognition system. It is like more number of like samples or images are needed. More training set size should be more, so we can't do that. It's time consuming. And same goes for hand text or speech recognition. As we said, we don't know how many columns does this. For example, if we have T like this, if T is like this, so this is occupying T is equal to 1, T is equal to 2. How many columns it will occupy, we don't know. And again, if we have T, we can, it can be something like only T is equal to 1, just one column it can occupy, or it can be something like this only. O can occupy half of like first column and then other column, or entirely O can occupy. So different cases are there. So this is time consuming. So for example, if we have annotated that also, there is one more problem. That problem is we get character scores. As said, if we have H here, E over here, this is H if you predicted, or example this is half H, this is half H, we will get 2 H's. If we get character scores, these has been obtained, whatever the things we are getting over here is because of they are having high probability. Like we have all the terms, dictionary terms, among that H has got high probability for suppose. That's why we are predicting H as a output, or we have some heuristic or metric. That's why we are predicting H and E in T is equal to 1 and T is equal to 2 for suppose. We have got the character scores, but for suppose now we are getting timestamp 1 half H, second like this, and E like this goes on. So we are getting 2 H's. So we need to process this, how to remove the duplicates. Sometimes over here we are getting 2 L's in hello. So this is not duplicate, this is not duplicate. If you have 2 H's, we need to remove this, but we should not remove this because hello contains 2 L's. So these things how we can operate. So here encoding decoding techniques helps us. And for example, if we have T T O O, so we need to convert this to T O. This is duplicate, then these two are duplicate, just we need these two. So and again, because O we are taking 3 or 4 because it's wide, it is spread across 4 timestamps. 2 means 2 T's means it is widespread across 2 timestamps. That's why we are taking that. So we need to remove all those T's and O's. But what if the recognition text would be TOO itself? So we will just end up after doing this processing, pre-processing or this processing, we just end up with 2. For example, this thing, can be TOO also, because these two, like this 2T is 1T, this 2 1 is 1, or this one. Or else what I can say is like this, we have, right, this is 1T which we want, this is duplicate one, and this is original one, this is duplicate, and this is original. So it can be like this also, or like this, we have, this is the original one and this is duplicate, this is the original one and these two are duplicates. So it can be TO also or TOO also. We need to differentiate among these. So even if we got a probability, like character scores, if we have got also, we need to do some further processing like encoding decoding techniques so that we can remove the duplicates, all those things. So for in this example, removing all duplicates, duplicate O's will be giving you TO itself. We should remove just one duplicate O so that we can get TOO as an output. So that's why CTC solved both the problems. Only text is needed in training. Like we need not to have like for each timestamp we need not to annotate that this is T, this is H, and if you have half H like this is also H, this is also H. We need not to annotate each timestamp. We just need the ground truth value. That means this is THH or this is hello. We need this text only. We have image and we as an input, and as an output we just want total text, not the character level or word level annotation. So we can ignore both the position and width of the character in the image. So we can ignore that and no further processing, like we have then in duplicates thing. So like TO or it is TOO. So for no further processing of the recognized text is needed. So CTC solved both these problems.